This is Math for Teachers 2, Lesson 25. So, missing value problems. So far, we've discussed different ways to solve missing value proportion problems correctly. With missing value proportion problems, there is one misconception that is very common among school children as well as adults. And in the next 5 minutes, you're going to work with your group to look at the following. Olivia picked out 8 posters that cost a total of $10. On her way to the checkout counter, she decided that she really wanted 12 posters. If all of the posters are the same price, how much will Olivia pay for 12 posters? Stephen thinks she will pay 14, and Joey thinks that she's going to pay 15. So I want you to hit pause, and I want you to think about which child is correct, and more importantly, why. Okay, so hit pause, take out a pencil, paper, think about the story problem. Stephen thinks that she paid 14, and Joey thinks that she paid 15. Explain how they came up with their answers, which one is correct, and why. Okay, so let's read the word problem again. Olivia picked out 8 posters that cost a total of $10. On her way to the checkout counter, she decided she really wanted 12 posters. If all the posters are the same price, how much will Olivia pay for the posters? Let's first look at Stephen. Stephen's thinking was 8 posters for 10, so 12 posters for 14. One possible reasoning here could be that Stephen thought that 14 is plus 4 from the original total of 8 posters for $10. So 10 plus 4 equals 14. And you may have a different way that you thought Stephen figured this out. This is invalid and not correct. Joey 8 posters for $10 and 12 posters for 15. Now, if we come back up to the word problem, there's some key language here, and it's right at the end. If all the posters are the same price, how much will Olivia pay for 12 posters? So, Joey may have divided 10 by 8 to find that each poster was valued at $1.25, because we know that all the posters are the same price. So $1.25 times her new desired quantity of 12 equals 15. And this is valid and correct. So missing value problems are often considered the beginning of algebraic thinking and the link between arithmetic and algebra. It's been argued that students with sound reasoning for missing value problems are better equipped to understand algebraic reasoning. Requiring students to have a sense of multiple strategies to solve missing value problems is one of the ways to develop their algebraic reasoning. But as you saw in the previous story problem with the 2 boys, that very often errors occur. So we need to, as teachers, understand what our children and students' thinking are. So in the next few minutes, you're going to go back to your workbook. If we were in the classroom, you could work with a partner. So if there's somebody at home that you can work with, that's amazing. Or if you can get together even on the phone with one of your classmates, awesome. Name, again, the strategy that the child is using, and explain if the child solved the problem and whether the solution is correct or not. If it's not, explain the child's error. Okay, so take a few minutes. The first child here to give you reference is Odella, right? So you're in lesson 25, and you want to go into your workbook, and you're going to hit pause now and work through each of the children. When you're done with all of them, come on back. Okay, let's look at the first story problem. Jackie is painting her house. For every 24 square feet, she needs 3 cups of paint. How many cups of paint does Jackie need if she has 96 square feet of paint? Odella came up with the equation of 24 divided by 3 equals 8 square feet per cup. So 8 times 96 equals 768 cups. She's using the unit rate strategy, but in this case, it's incorrect. Hit pause and identify where she went wrong, looking at the story problem and her equations. Okay, let's move on to Ronnie. Same story problem. If it helps you to hit pause and reread it, think about that. Are you reading it out loud? Is this how you would type it up? Would it be centered? Would it be to the left? And thinking about these little things. Is this font large enough if you were to present this slide? All right, on to Ronnie. Ronnie says that 3 cups is 1/8 of 24. So 1/8 of 96 is 12 cups. Okay, 3 cups of paint is 1/8 of 24. Every 24 square feet needs 3 cups of paint. So mental math, 3 goes into 24 8 times. So 1/8 of 96, the total square feet she wants to paint, equals 12. This is scale factor across unit strategies, and this is correct. If we drew a picture of Ronnie's thinking, similar to what Sam drew from the previous lesson, think about how we would draw that. Hit pause, review the video, making sure that these visuals make sense to you as the future teacher so that you can explain it to your future students. Jessie. How did Jessie solve the problem? Okay. 4 times 24 equals 96. So 4 times 3 equals 12 cups. How did he get there? Writing down, it's really helpful. Think about how he got there. Okay, so if we drew a picture for Jessie thinking, again, going back to Sam, so 3 cups times 4 equals what? And 24 square feet times 4 equals 96. So 4 times 3 equals 12. How did Sally solve her problem? She used the scaling up and down strategy. So Sally started with 24 square feet equals 3 cups of paint. For every 24 square feet, Jackie needs 3 cups of paint. So 8 square feet equals 1 cup. 8. 3 into 24 gives us 8. So 80 square feet equals 10 cups. But we're not there yet. We're not to 96. So, mental math. What do I need to add to 80 to get to 96? Well, 2 times 8 is 16. So 16 square feet equals 2 cups of paint. So 10 cups and 2 cups equals 12 cups. And then double check that math. 80 square feet plus 16 square feet. 0 plus 6 is 6. 8 plus 1 is 9. And that gives us this story problem. She's trying to paint 96 square feet. Okay. How did Michael solve his problem? Same problem. 24 over 3 equals x over 96. He tried to use cross multiplication strategy. He got 768 cups, which we now know is incorrect. So break this down and think about how he should have done this. So which of the strategies do you think are best in terms of making the computations easiest? Either Sally's scaling up and down strategy or Jesse's scale factor within unit strategy, because the numbers were all small whole numbers. So really, depending on the numbers involved in the problem, you're going to use different strategies. As you become more comfortable, you'll become more comfortable speaking the language and explaining to your students. So many students and adults notice a pattern of 3 given quantities and 1 unknown quantity, and automatically assume that they should set up a proportion or a cross multiply scenario to solve. However, determining if a problem requires proportional reasoning or active reasoning involves the following. 1, proportional reasoning is required if the multiplicative relationship between the quantities remains constant. And secondly, additive reasoning is required if the difference between the quantities remains constant. These are a lot of words, okay? Again, you can see the bolded vocabulary and important words here, but go back. This is the end of the video for lesson 25. But again, if you got stuck or you went, I didn't quite understand how one of the children solved it, go back now. It's worth the investment of time to ensure that you understand these clearly.